Hello! This is sort of a demonstration of the little game I've developed so far. So basically, as you can see around here, now a little disclaimer beforehand, some things such as the noise used to generate the terrain as well as the base, like marching cubes algorithm, I did not develop myself, but instead I got that from online sources, and other things such as the music and so forth, like sound effects, I have sourced from online. However, things such as chunk loading, as you can see here with how the chunks seamlessly load, I'd say it works pretty well, but nonetheless the way it loads, basically animations like this, bullet mechanics such as when I fire, ricochet, sort of flash, there you go, a bit more, there. And then some other things, such as maybe the dynamic fog, dynamic fog in Unity isn't exactly a difficult thing to hassle with, but nonetheless, I achieved it with a seamless sort of view. And also things such as, like I said, the noise, and how it generates the terrain with all the vertices and the voxel data such as that is all stored in a dictionary. So basically it can be saved and loaded. And in the future, modification of this dictionary via just manipulation, like maybe with a tool, like I guess we'd say a mining device of some sort, would definitely be plausible. Of course, I haven't implemented it yet, but in previous versions, without this chunk loading feature, it has been working. Another thing to note is that the chunk loading is highly multi-threaded, so it should run seamlessly. As you can see here, if we fall down, it loads pretty well. This is due to the Unity job system, which I really am passionate about. However, initially I did not like it, but I learned that C#'s thread system, along with it, is pretty handy when it comes to optimizing games. Now, another thing you might notice is the clouds, or not clouds, but the fog will change color as I go deeper into the world. And so I put a flashlight on my character, of course, so I can actually see down here. And while the sun from above, I'm definitely going to work on that being a little bit more prominent, even in the very base of a cave, like the start of a cave. Still has a nice view to it, sort of. And then sort of texture changes, if I can find it, yeah, like this, with some purlin noise textures, so it looks a bit more colorful as opposed to just instantaneously changing. And then you can go down, and I don't think I set, I didn't set the cave density or cave height layer to be too large, so if we fall down here, there should be a underwater lake. Yeah, as you can see, the texture changes, and so does the whole atmosphere. You know, the fog, the shape of the of the noise used for the land, sort of everything kind of changes to this more sea-esque tone. And I am yet to incorporate a water plane and water fog to really emulate the effect of water down here, but it's definitely going to come within the future. Another thing that you can see is the top of the terrain, or of the cave, of the cave over there. Basically, this is just loading chunks constantly, and when it runs out of chunks, basically, or chunk data, it'll just generate it anew. And then we can come back over here, and it'll just reload previous chunk data. Now, the way it works is we use the same chunk array, or same chunk list, to basically iterate over each, to basically make each chunk, and so forth. So basically we're reusing chunks instead of instantiating new chunks, basically to save on memory, as opposed to creating a bunch of new chunks and, well, just being a little bit of a hassle. Instead of doing that, we basically make an array to store data, or a dictionary, a dictionary of arrays of floats to store all the voxel data. So basically what that allows us to do is, like I said previously, modify or generate that data on the fly at a much lower cost. And we can simply use a method within my chunk class to simply generate or regenerate these chunks. Of course, reposition them and then regenerate them with new voxel data. Basically, this also allows us to potentially, let's say if I want to modify this, I haven't incorporated it yet, but if you want to modify this chunk right here, I don't know how big this chunk is, it could cut off there, could cut off there, I don't know. Anyways, if you wanted to modify it, it would not be difficult. And so far the engine can handle about 20 to 40 chunks of frame with approximately 100 frames per second on my system. Of course, that's just my system, but when you incorporate the fact that before, without multi-threading, it would really tank the CPU, it's definitely an improvement. Now, there's also my item system, like item sway, and while my HUD isn't exactly pretty, it's definitely, there's a new one definitely in the works, and so forth. If there's gun firing like I showed you, like bullets should be able to reflect like that. Yep. And so basically, how I avoided Unity basically ignoring the collisions between a fast object and a stationary object is basically just ray collisions, you know, where you take a ray cast and then take a ray cast from the delta position of a bullet and the current position, and then you check, hey, is there a gap or is there an object that we're intersecting from this ray or line? And so basically, if there is, you set the point, or you set the collision, or you set the position of the bullet. So let's say maybe the position was right there on that vertice, or vertex, whatever. And let's say the bullet was collided right there. Basically what we'll do is we'll reflect across the normal. So, well, that's too shallow of an angle. I also incorporated an angle mechanic, so if it's too shallow, it won't bounce off and instead just sort of impact into the ground. But if you do a shallower angle, as opposed to a steep angle, it does reflect. Also, I used a little light source on the bullet to make it a little bit more graphically pleasing, as well as using a texture to give it a higher emission, which also kind of gives it a nice sort of bullet-esque tone. A little bit more fantasy as opposed to realistic bullets, which don't really shine like that, but it's still a nice feature for the cartoony style that I'm trying to achieve nonetheless. Another feature is you can drop items like so by pressing backspace, and while the dropping system isn't the best as it can sort of nudge you, it still works pretty well. You can pick them up and the ammo you still have obtained is still there, and of course there's the picking up icon on the top. Now, this is all I really have so far, including ammo, the ammo system. So if I just see, it can no longer fire because we've drained its ammunition. So basically how I store ammunition values is like a dictionary. I use a string as a key and an integer as a value for, you know, how much ammunition is left. Same thing as with the shotgun. It's just I haven't exactly picked up the shotgun ammunition this time around because it probably fell from the map. Another thing to note that is a bit problematic is because of how the chunk loading system works, it means that collisions won't exactly happen beyond the render distance. So I believe I've said 8 chunks render distance on each for like each half side, so it'll go 8 chunks that way, well 8 chunks that way, and so forth. And so basically collisions will not occur once you basically exit that area. Basically what that means is if an object is still active, let's say right here, and you walk away from it so that the chunks basically re-render or re-modify on the other side, or like where you are currently, will basically just fall through the world. And that's of course something that can be fixed by just having it cold when you're a certain distance away, where it detects that it's not in a chunk, which is a simple fix in itself. So that shouldn't be a huge problem. Another thing I plan to work on is generating a navmesh at runtime. This would allow for the capability to have basically enemies be able to walk around seamlessly. And while I have tried to work around with it, it isn't the most efficient at the moment, but that is definitely, like I said, something that is in the works. I am using for that the navmesh components, provided by Unity Technologies, which are, in my opinion, a very handy tool. But of course, I will definitely look into potentially creating my own navmesh generator so that I can seamlessly create my own navmeshes, basically as the chunks load, as opposed to doing it on the main thread. And to be fully honest, I'm not too sure how the navmesh component system works, because I haven't looked too deeply into it. However, if it is not multi-threaded and runs on the main thread, I will definitely change that, and so to make it use the job system, because I don't entirely know if it's up to date with the job system, because I did realize that technically the job system is relatively new with Unity, so yeah. And there should also, another thing to mention is I have had growing trees, and that's why this axe is here. The thing is, though, the trees did have a little bit of a performance tank on the CPU, because I did use an asset I did modify called, I believe, procedural trees. Not Unity's procedural trees, but a standalone free asset. And so basically what I did to modify it so it would more accommodate for my game is I made it so that it would, one thing it would do is it would make every triangle share at least a couple vertices, and so basically what you have to do, this low poly sort of distinct normal effect, is you have to separate each and every vertex, and so that's something I did so it achieved this effect. And so basically another thing I did is I incorporated basically the idea, or the capability for it to grow, sort of, by just regenerating the mesh, but with a higher maximum sort of vertex count. And of course, if that vertex count would grow over time, and so would the tree, sort of virtually. Now, like I said, this would be kind of tanky on the system, because that would be a lot of calculations per every couple of seconds, which would add really weird frame dips, and something I really like to focus around is optimizing the game using the profiler and like the hierarchy to make sure, hey, what is the problem? Or hey, is this the thing that's causing the problem? Or frame dips? Because in my opinion, it's better to, you know, fix a problem as opposed to moving on and then fixing it later when it's even bigger of a problem. Because it's nice to have a game that most people, or more people, can play. Because, you know, if you want your target demographic to be gamers, you know, you have to be able to adapt to what their systems are, and so forth. And that sort of concludes my little demonstration of the game I have developed so far, and yeah, I hope you enjoyed, and I greatly appreciate if you watched it to the full extent. Thank you.